and I'd like to welcome you all here, and I'm happy to present OpenAIRE in this webinar, and I'm glad to have been invited by FAO. So today it's an introduction about OpenAIRE and its guidelines. I will explain briefly the OpenAIRE project and infrastructure. Then I will relate to what it means open access in Horizon 2020, and of course a story about the OpenAIRE guidelines, why we have them, how do they work, and I will end by giving future directions of the OpenAIRE guidelines. So OpenAIRE is actually a project, but also an acronym which resolves to open access infrastructure for research in Europe. This project is now in its third funding phase. It started actually 5 years ago with the first phase of OpenAIRE to monitor and implement the open access pilot in the European Commission Framework Program 7. And over the years, it developed to one of the key infrastructures of the European Commission and is now responsible for implementation and monitoring of the open access mandate in Horizon 2020. At the moment, we aggregate more than 13 million publications. Most of them are open access, and linked to about 11,000 research datasets or datasets that are a result of a funded project. We have registered about 700 data providers, which span to over 6,000 open access journals and repositories. OpenAIRE is both a project and an infrastructure, and is mainly guided by open access funded policies, and of course mainly by the policy of the European Commission, but also by other national policies from funders in Europe, in the European member states. OpenAIRE is now a project consisting of over 50 partners from all EU member states and associated states in Europe. And it is not only a technical infrastructure, but also allows for participation by humans. That means that OpenAIRE is represented by so-called national open access desks in all EU member states. And of course, it has a public entry point via the OpenAIRE portal, allowing researchers to deposit, search, and discover research results, and is also an opportunity for project coordinators to either link their research results to their project or to gather consolidated lists of publications from their projects. The technical infrastructure is some kind of an integrated scientific information system with main entities that are interlinked, such as the publications, the data sets, authors, organizations, and projects. And the main pillars of the technical infrastructure are, of course, the data providers that come into the OpenAIRE platform and services that operate on the information collected from data providers. That means that OpenAIRE collects from data providers like funders and CRIS systems authoritative data about their projects, from institutional and subject repositories and open access journals. We collect bibliographic metadata, and more also we collect full text files for text mining purposes. And we aim to collect from data repositories information about their research data sets. In order to enter the OpenAIRE infrastructure as a data provider, we perform some validation routines to make sure that the protocol of the data provider conforms to some rules and that the metadata are compliant to the OpenAIRE guidelines. Then we have some cleaning and transformation rules to normalize the metadata if necessary and transform them to an internal presentation for further processing. We have a deduplication service in place. What that means I will show later. And a module responsible for data and text mining, which allows to infer knowledge, especially from full text files. And of course, we want to interlink all these different kinds of entities I mentioned earlier. As services or output of OpenAIRE, OpenAIRE provides its portal for discovery, allows to monitor and report ongoing progress of research results per project. It exposes the OpenAIRE API via different interfaces like REST and OAI PMH. And more sophisticated services like classification, clustering, analysis, and statistics allow for evaluation and impact assessment of research results. In the following 2 slides, I want to give a summary of services we have in place. In this first table are OpenAIRE services which are currently in production. So, for instance, we have the validation and aggregation services that target, of course, the data providers. What is worth noting here is that we do not only want to validate data providers once they enter and register to OpenAIRE, but we want to extend it in a process to continuously validate metadata records and feedback this information to the repository managers. There are cases where a publication or a research data set is not available in a repository or cannot be harvested by OpenAIRE, but needs to be linked to a project or needs to be interlinked between a publication and a data set. Therefore, we have claiming functionality allowing authors, researchers, project coordinators, or other people to interlink their research output or link it to funding. For authors, we also provide guidance where they can deposit their research outputs, allowing to locate an appropriate institutional automatic repository or data repository. As a background service, OpenAIRE operates several algorithms for text and data mining. The purpose is mainly to extract project references, cited data and publications, or to extract reference lists. Then, of course, we have the OpenAIRE portal for search and discovery facilities and the API for machine access to all the information available in the OpenAIRE information space. OpenAIRE offers monitoring and reporting facilities, and as some kind of pilot started in spring this year is the FP7 Post-Grant Open Access Publishing Fund, which allows authors from Framework Program 7 projects which already ended to reimburse their author processing charges. And this way, the European Commission and OpenAIRE, of course, want to make sure to increase the numbers of open access available research publications. And this table shows some services which are currently in preparation or in development. Starting with the data literature interlinking service, this is an outcome of a collaboration between several stakeholders in the context of the Research Data Alliance Publishing Data Group. The target audience, of course, is the research community, and the advantage of collaboration between data repository managers, publishers, and infrastructures like OpenAIRE is to generate high-quality, trusted links between research literature and research data. In preparation is the so-called open access broker service. Maybe you know already the share notification service or the JISC broker service. The service in OpenAIRE will work in a quite similar way, which will allow for notification and distribution of enriched metadata to repositories or other data sources that subscribe to the service, and will allow, for instance, to notify such repositories if OpenAIRE encounters a project reference to a publication which is not yet known in the metadata of that repository, or it will allow to notify the repository about a paper of an author who is affiliated with this repository institution, but that paper is available in another repository and available as open access. Third, we prepare and running a pilot at the moment regarding usage statistics and analytics services. This will help, hopefully, repository managers, authors, but also funders to assess the impact of research output. And we see this also as a contribution, and we want to connect to other initiatives working on article level metrics. We also develop a service where we interlink all the research information available in OpenAIRE in a linked data way. So the plan is to publish the content in the OpenAIRE information space into the linked data cloud and make it available to knowledge discovery services using semantic web technologies. Also currently running is a tender project on open peer review, which is a pilot where prototypes will be developed towards tools and workflows to implement open peer review to allow for alternatives to classical peer review methodologies. And the constraint is here, of course, that the prototypes have to be aligned with the OpenAIRE infrastructure. Next, I want to show you how an enriched document as a search result in the OpenAIRE portal looks like. And maybe there could be a question where all this information actually comes from. So first, we have the plain bibliographic information we usually aggregate from the repositories. And it could be in many cases that the same document is available in multiple repositories or was published in open access journals. And we merge this information in a single representation. But of course, we also keep provenance information, which means we provide the information where we originally collected this information and where the research data or the publication can be downloaded from. Then we want to link, of course, research output, if possible, to funding details. And these funding details can either be provided in the metadata or are extracted from the full text by text mining. And finally, also as a result of text mining and inference services, we provide a list of references to other publications or links to related research data, or provide a list of similar publications, similar about the topic, for example. Now I want to show you a typical user workflow. So, for instance, there's a research team that has received a grant, and the question here is how useful could be projects like OpenAIRE and other e-infrastructures, so that these researchers have good opportunities to facilitate their research. So usually they make use of a fast network. They use some kind of authorization services, and maybe they already have some kind of identifier like ORCID. And the question is often what similar research results are already available, and what other researchers or organizations are working on similar or the same topic, and which might be worth to collaborate with. Then there could be the question, and maybe they are asked in the funded project to create a data management plan, and the questions are like which data will be generated or will be reused, how will it be cleaned and stored. And there are some projects available that guide such researchers, like the Foster project in Open Science, EUDAT, in particular about questions regarding research data, and OpenAIRE. The question will also be where to store the research data, how to describe them in the metadata, how to preserve, how to provide long-term preservation, how to curate them. And here are some infrastructures and projects come into place like Tor, EUDAT, OpenAIRE, INRA, FAO, and other infrastructures. Questions will occur, what tools can be used to process and analyze the research data? Where can they be run? What facilities are available? How can the data be transferred? And infrastructures like EGI, European Grid Infrastructure, and PRAISE are dealing with these questions. Another important topic is regarding methodologies for text and data mining, which are currently discussed in OpenAIRE, but also in OpenMinted and EGI, to analyze the situation from a legal point of view, but also regarding technologies and workflows to ease and allow for text and data mining, and also to allow to publish results from text and data mining. And next are questions, where can all these results be published? Where OpenAIRE, EUDAT provide guidance and facilities, and where registries like the directory of open access journals, provide information where to best publish results, where registries like OpenDoor and ReThrough may locate to a proper repository. So what I wanted to explain with this slide is how different kinds of e-infrastructures work together towards realizing a way supporting open science. So what does open access in Horizon 2020 mean actually? First of all, there are more and more funders that stipulate open access to research results. They have open access mandates more and more in place. But then the question is how to find these research outputs linked to projects. And there are actually two ways. The one that requires more effort is to analyze it by text and data mining in full text files. And the second way, which actually is more efficient but requires structured documentation, is to link research results with funding in metadata. As said, the European Commission introduced open access as a mandate in its Innovation and Science Framework Program. And this is stated in the General Model Grant Agreement document, where they say that it has to be ensured open access as soon as possible and at the latest on publication. Deposit a machine-readable electronic copy of the published version of final peer-reviewed manuscript accepted for publication in a repository for scientific publications. There's also a similar document, a fact sheet on open access for publications and data, where the European Commission details some metadata properties they asked to find in metadata related to the research output, mainly the publication. So they want to make sure that the European Commission is mentioned as the funder, as some kind of acknowledgement. In the metadata, it should be stated that the publication was peer-reviewed. If applicable, the embargo period needs to be stated. Project information needs to be provided. And if possible, a persistent identifier to the research output, which can be the DOI or URN or some other kind of persistent identifier. Then it is important to provide a license about the research result, to indicate if free access is allowed, text and data mining is allowed or not allowed, etc. What is more, a recommendation from OpenAIRE is to ask to provide a persistent identifier about the authors and contributors, for instance, as the ORCID, or to provide references to related research outcome in the metadata. So as you see, there's some guidance necessary how to provide this information in a structured way in the metadata, and therefore we defined and disseminate these guidelines for data providers. And one aspect to consider is also what kind of information OpenAIRE actually wants to collect. Of course, these are bibliographic information about publications from institutional or thematic repositories, which are either open access or related to funded content from the European Commission or from any other national or other funder. On the other side, we also want to collect metadata about research data or software or other kinds of research output that is somehow related to a publication. Therefore, we actually don't want to collect data set where we cannot find any context and where we think a data set which is without context is not useful to the research community. So we require that the data set should be linked with the publication, hopefully available in the OpenAIRE information space, or at least the data set is related to some kind of funded project. This collection of bibliographic information from repositories is complemented in the same way by collecting this information from journals, publishers, or other kinds of aggregators. So for instance, we collect the metadata from DOAJ, which are about 2 million records at the moment. And we do this also from DataCite. And more or less we use this kind of information as some kind of reference metadata. And that means we cannot really rely that these metadata complies with our guidelines. So we need to put some kind of record regarding the metadata normalization. And in some cases, we also support additional APIs that are beyond OAI PMH for metadata collection. Where then we collect from individual journals or data repositories, we expect that they can provide us with more detailed information. So that the metadata contain information about grant IDs, funders, cited data, and links to full text. And in these cases, of course, the OpenAIRE guidelines come into place. Because we collect from different type of data providers, we have at the moment 3 different guidelines. The most important ones are for institutional and thematic repositories and journal platforms, where we currently rely on Dublin Core using OAI PMH. And these guidelines have its roots in the driver project, where the driver version 2 guidelines were published in 2008 and have been established, especially in the research repository community, but also, for instance, in OJS platforms over the years. Second, we have guidelines for data repositories, which rely on the DataCite format. And we have guidelines for CRIS systems, current research information systems, which expose the information in the serif XML format. Serif is the acronym for the Common European Research Information Format, and I will explain what it means in a few minutes. So the literature guidelines have had a long history since 2008, and therefore different versions are in place and also currently supported. The minimal requirements are is the so-called OpenAIRE basic level, where we expect to find metadata records which refer to open access publications, and according to the guidelines should be grouped in an OAI set called driver, but that is for backward compatibility. In the first phase of the OpenAIRE project, we introduced guidelines to identify grant IDs, where the publication is a result from a project, and therefore we had introduced the OAI set EC funded resources. That was around 2010-2011. And then in the context of the OpenAIRE Plus project, a few years later, a merge took place from the former driver infrastructure and the first OpenAIRE infrastructure to a unified information space. And the result was that we had to support two different guidelines, and also repositories were asked to provide this information in different ways. For instance, dedicated OAI-based URLs just for open access content and those for EC-funded content. And therefore, there are also two different sets supported, driver and EC-funded resources. In the next step, we tried to consolidate this rather complex situation by introducing the OpenAIRE 3.0 guidelines, where we expect now to have all the open access related records and records related to EC funding or related to funding of other national funders in a single OAI set OpenAIRE. And this is now also the recommended version data providers, institutional thematic repositories should support. The original already said is the OAI PMH protocol, which has as its lowest common denominator the OAI Dublin core format, consisting of just 15 non-qualified elements based on the Dublin core metadata schema. The problem here is that it is used in numerous interpretations, and that causes, of course, interoperability issues, because everybody tries to interpret the content of a Dublin core element in its own way. And this was considered in the driver project, and therefore the driver guidelines version 2 was introduced in 2008 as an effort to agree on a common syntax regarding the protocol and the metadata format and semantics by introducing some kind of controlled vocabularies. And these controlled vocabularies are manifested as the InfoAIRE repo application profile, which encodes information, for instance, about the publication type, encoding of funder and grant information, the access status, and some other kinds of vocabularies, for instance, also about classification information. The driver and first OpenAIRE guidelines relied mainly on textual resources, and the scope has been expanded with the OpenAIRE guidelines introduced since 2009. The guidelines are available under Guidelines OpenAIRE EU. The main properties are about the project ID, which we asked to encode using the InfoAIRE repo grant agreement string. We asked also to encode the access mode or access rights to the resource in a standardized way. If applicable, we asked to provide the embargo end date of an embargo period. If possible, to provide alternative identifier which resolve to the same resource, for instance, a DOI in addition to a landing page in a repository, and links or references to related datasets or publications. Similarly, we have the guidelines for research data repositories relying on the DataSite metadata schema. And Zenodo, for instance, as a hybrid repository, serves as some kind of reference implementation of these kind of data repository guidelines. There are only a few adaptations for OpenAIRE, but in principle, it's compatible to the original DataSite metadata standard. We also have guidelines for CRIS managers. As said, they rely on the Serif XML data model and metadata standard. And it is known that serif is a rather complex specification, and therefore for OpenAIRE we rely only on very specific entities, like about the publication and the dataset as results, funding, person, project, organization. And we hope to register the first CRIS serif compliant data source either by the end of this year or beginning next year. Especially for the literature guidelines, there are a number of add-ons, pages, and plugins available for different platforms. I think best supported is DSpace, but also ePrints, OJS as a journal platform, and in Germany might be known the Opus and Micro repositories, which are supported with guidelines version 3.0 compatibility. The DSpace add-on is now compliant with OpenAIRE 3.0 guidelines and allows also to import project information from different funders and encode it in a proper way so that we can extract grant IDs in OpenAIRE relative to funders like the European Commission, Wellcome Trust, or national funders. In this case, for instance, FCT is a Portuguese funder. There are a few steps to be considered in order to make the repository compliant and registered in OpenAIRE. We have the validator service, which allows to test the compatibility. We ask that the repository should be registered in OpenDoor, or if it is a research data repository, in re3 data. As a next step, the data source can be registered and will then be aggregated and indexed. And we will take care that the repository manager will be notified once this registration and indexing is successfully completed. The data provider or repository manager has always the possibility to reconfigure for instance, the OIP settings in the validator service. And in preparation, as said, is the facility for continuous validation of metadata records and reporting back to repository managers. And we are also preparing some kind of service level agreement, which will more support also in a legal way text and data mining of full text files. Okay. A short outlook about the future directions. This has a political aspect. There are, of course, other regional repository networks in the world. For instance, La Referencia in Latin America is a large open access repository network, and we agreed to collaborate towards the infrastructure, but also towards the guidelines. And then, in order to introduce more innovative scholarly services, so beyond the organization and political network alignment, some work needs to be done and agreed also on the technical and the metadata level. And therefore, initiatives like La Referencia, Share, RIOX, and OpenAIRE work together, for instance, in the context of the COA CAS-RI Open Access Interoperability Working Group to agree on common and aligned metadata elements and vocabularies. And we also have the core interest group controlled vocabularies, where we work towards the substitution of the InfoOIRE repo application profile by more up-to-date ways to express controlled vocabularies. And we also have a first draft of the resource type vocabulary in place, which is based on ESCOS. I have tried to provide links, and I hope they are also available when this presentation will be published, so that you can follow these links for further information. We identified some issues that needs to be improved regarding the metadata quality. So, for instance, features we want to disambiguate authors, contributors, funders, projects, and links to other research outputs. So we need to have identifiers in place and a structured way to embed this information in the metadata. We want to find explicit links to landing pages or full text files in metadata. At the moment, for instance, we provide a URL and DC identifier, but actually we don't know the meaning of this kind of URL. We want to be able to provide dedicated and semantically tagged links between publications and other research output. We require more detailed bibliographic citation information, which cannot be easily described in the Dublin core or even not in DC terms metadata schema. So we need to introduce some more granular metadata format. And of course, it is more and more important to provide a machine-readable way of license information, for instance, as a URL of said license. And there's also a need to upgrade the repository platforms from the technological point of view, for instance, that they also more and more follow linked data principles. And we expect the requirement to be flexible and allow extensibility of the metadata format to introduce future properties regarding open science, for instance, criteria regarding data quality and reusability of research data. On the other side, we want to try as much as possible to be backward compatible on the OIDC approach. Okay, this is the end of my presentation, and I now open the floor for questions.